All right, we're recording. All right, we're up and running. All right, so I already made this video at lunchtime, and for whatever reason, I might have hit the space bar or something. Didn't work. So literally going to do this very fast. So it's really mechanical practice you're getting here. And any questions you have about what's going on and why, please ask tomorrow morning. You want to have those conversations. They're more important to you than the mechanics, because through those conversations, you're going to get a feeling for the origins of each problem, I hope, what I think the historical origins are, what are the most salient characteristics of whatever we're looking at, what's important. All right, so I've got the problems on the other side of the room, but I'm not going to move the computer around this time because I think moving it around the room is what cost me that 45 minutes at lunchtime. So the first question was write the equation of a line through -5, 7. And I'm hoping that this is like butter for you right now, 5, 3. So we have y equals, we're going to write x plus 5. So when I put -5 in, it's a 0. I want a 7. Boom, I just made that happen. When I put 5 in, I get 10. 10 plus 7 is not 3. So I don't want that 10 units of change, where the change is happening. That's a constant. The change is here. The change I want is 7 to 3. And I hope this time is at -4, because you're going down 4 units. Okay, so that's 1. That's problem number 1. Problem number 2. We're going to write, so we got 3/11ths, x plus 2 minus 5. And we got y. If you're dividing by 11, you want numbers like 0, like 11, like 22, like 33, so on and so forth, right? Because those would be user-friendly and you don't have to think. So what makes the 0 here? Sure looks like -2. So -2 is going to get us -5. What makes 11 out of this parentheses? I guess you want to put a 9 in here, right? Because if I put a 9 in here, I get 11 divided by 11, which cancels, and I get 3 minus 5, which is -2. So there's 9, and there's -2. And I think we can already see that I went up 11. Well, why don't I keep going up 11? I go up 11, 20. 20 plus 2 gets me 22. Yes, that's nice. And so now I get 22 divided by 11 is 2. 2 times 3 is 6. 6 minus 5 is 1. We could just keep doing that, right? We could do 31, down 3, down 4, down 3, down, up 3. Sorry, up 3. Going up 3, up 3. I don't tire here. So 31, 4. You keep doing that. We've talked about that in class. So now we want to take this and put it in mx plus b form. Yeah, that's what every algebra 1 teacher hammers you with. And then you stop using it and you get the calculus. So what do we got? We got 3/11ths x. That, I'm hoping everybody understands how to multiply those fractions now. And -5, I'm going to take a little shortcut, is -55 over 11. I can see 11 times that, gets me that number. And so slope intercept form, 11x plus minus, what is it, 49? 49 over 11. Okay, so how would you graph that? That's a little more than down than -4 units, so that's minus 49/11. That's your y-intercept. And you're going up 3 over 11, or you're going up 30 over 110. It's a ratio of change. Probably shouldn't have done that to you, but it is what's going on. So up 3 over 11 is the way the numbers are changing in terms of rate. And we have located the point 0. Put 0 in, you get -49 over 11. And that's why it's called y-intercept, slope-intercept form. I'm talking too much. 5x minus 4y equals 40. So this is number 4. 5x minus 4y equals 40. The easiest way to get that line is simply to plug a 0 in. -10. All right, 0, -10 is down here. And then put a 0 in. Like covering it up, you get an 8. So 8, 0, 0, -10, and you got the line. Okay, that's what you wanted. You wanted a sketch. So now we're going to sketch y minus 5 equals -2/5 x plus 4. Y minus 5 sure looks like y equals 5. It's helpful here. Equals, what was it? -2/5. X plus 4. So this is point slope form of a line. point slope, so we gotta find the point on the line. I know 5, I put a 5 in on this side becomes 0. And I know when I put a -4 in here, that side becomes 0. I know that's an X and that's a Y, so I guess it passes through the point -4, 5. And let's call that -4, 5. What are you doing? You're going down 2 over 5. Boom, get yourself on a nice piece of graph paper. Point slope form. All right, could do a little better job here, but I am in a hurry. All right, so -3/7 x minus 6 equals, oh, why don't we graph this right now? -6, why -7? 0, -6. Going down 3 over 7. Let's call that down 3. It's a little more than 3 based on that size. All right, I'll cut it off. Over 7. All right, so I got this line that's doing that, decreasing at a -3:7 ratio. And we want a height of -5. Well, -5 is over here. All right, that's higher, -5. And the graph of y equals -5 is a constant. So really, you have two lines. And we could have written this in linear form as 0x minus 5. 0 means I'm not going up, I'm not going down, I'm going across at a 0 increasing rate. Say that better somehow. Okay? But we don't write 0 times x because you don't have to. All right, so what do? We guess what that answer is. It sure looks like a small negative. What's the quickest and easiest way to get it without thinking? Remove the -5 there. Add 6 in your head. You can add 6 to -5. I'm sure you're all capable of that. That has moved. Division by 7, multiply by 7. Now you're thinking in terms of inverse operations, which is going to serve you a whole lot better than the scales of justice. Do this to this side, do this to this side. Multiplication by -3, division by -3. And put the negative in the numerator. Is that a small negative number? Does it look like that might be -7/3 for an x? Now, if you want to find the y, it's not too hard because you already know what it is. -5. All right. -4x plus 5. Same kind of problem. I'm running out of ink on this one, so let me find another one. Bear with me while I find something that appears to have, that doesn't. This red one looks good. Oh, it is good. All right, so now I'm on problem number 7. Problem 7, -4x plus 5. Another linear function. I might as well graph it. Y equals 5, 0, 5. I like repetition. I wrote it there because I know I'm going down. That's not going to be in the way. So down 4 would be about to there. Over 5 would be about to here. That's a pretty good graph. I took a little more time with it. I'm pretty happy with that. Okay, and now I've got to graph 2x plus 14, 2x plus 14, and I want to see where these graphs intersect. That's 5. I'm going to erase this. I'm going to leave that there. So 14 would be maybe here. That looks pretty good. And a 2-to-1 ratio, so I'm going up 2 over 1. Looks something like that. So we want to find this x value. I think it's a pretty good graph. So that's 5 units. We try to do a good job here. That's 5 units, then this y value, this x value, looks to be around 3 or 4. Something around 3 or 4, and it's negative, sorry, it's negative. So I'm going to do the algebra now, and this is -4x plus 5. I hope you can see that. Let me check. That's an equal sign. Let's write it better. -4x plus 5 equals 2x plus 14. All right, so I got that finally right. I think you've heard me say for a day and a half now, 2 days, I don't like dividing by a negative. So I'm going to add 4x to this side, which is 6x. I'm going to subtract 14 here, so that gives me -9. And so now I have -9/6, which is -3/2. I don't like my estimate. I thought I was near a -3 or 4, but I'm sure it's still good. All right. So I got to do a better job of my 5, 10. Yeah, probably would have been here. Yeah, that's going to bring into it. Yeah. Anyway, we're just confirming with some rough graphs. And I just confirmed that I like my answer. Number 8. Okay, I think you can do this much better now than yesterday. X plus 6, all the time you spent all the time that you spent this afternoon factoring, right? So I'm hoping you're seeing that as x squared plus 2x minus 24 without me having to FOIL it. But I will FOIL it because it is a hallmark. So we got x times x, which is x squared. We got x times minus 4, which is minus 4x. There's your 6x. There's your minus 24. So there's your positive 2x because those terms are alike. And I think you're going to get that right now based on what I saw you do in the afternoon. I don't think I have to talk about that too much more. All right, so now we're going to expand minus 3 times. I want to do this. This is the second number 8, but I know the next question, number 9, is really kind of based on this. So number 8, the first number 8 is minus 3x minus 4 squared plus 7, I believe. And I hope you can see that 4 comma 7 seems to be a very important coordinate here. And it is. It's what gets us a cup shape down because it's an x squared graph. So that's your vertex. And that's all I'm going to do. I'm not even going to find the y-intercept here. I'm just going to say that much we should know at this point. We're trying to know. All right. And so, oh, I did ask you to expand it. All right. So we're going to expand it now. And that's minus 3. And now really what you're doing is x minus 4 times x minus 4 plus 7. And you should do this first. It's the most challenging part of the problem. And then you're going to multiply everything in here times negative 3. I'm hoping we're getting better at that. I'm hoping we can start to see the shortcut, which is x squared minus 8x plus 16. I know a bunch of you already can. And those of you who, want to find that shortcut, you don't have to work so hard. Do this out. Then look at it. You'll see a pattern. And that's what you're after anyway, is practice seeing patterns. Right? And that's the most important thing coming out of a math class is the ability to see patterns. I don't care if you're in a math class or you're a therapist, patterns are important, right? So somebody comes in and goes, that dog's driving me crazy. Then the next week, that dog's driving me. Therapist might say, I think I'm seeing a pattern here. Little anger management around the dog. All right, so now, what's your final answer? Minus 3x squared plus 24x. Hopefully, you're watching minus times a minus. That's where you got to be careful at this level. Minus times a positive plus 7. I got the marker or the eraser, so I'm going to write minus 41 now. I think that's right. Okay, so if I make a careless error here, it's because I'm really rushing too fast, and I apologize, but I've got other commitments. So now where are we at? We're at, 3x squared minus 12x plus 7. So we're looking at 3x squared minus 12x plus 7. Depending upon what I get in, put number in, I put in for x, will get me different variables, different values. And we use the letter y to represent the different values you get. Now this was a cup shape down. We said you can do that really quickly. So this is a cup shape up. Okay, and we want to be able to sketch it. So we want to be able to put it in this form. Right? Well, I can see the minus 3x squared here, right? I can see that from that. So let's start it that way. Let's start with 3 times x and put a square there. Well, the question is, what is the way that we find that x value with vertex? Because it's a graphic form. If I don't know the vertex, I don't have command of this thing at all. So hasn't popped into your head yet. You want what to pop into your head? Minus b over 2a, the average of the roots. Okay, the average of the roots. So minus b over 2a is, in this case, 12 divided by 6 is positive 2. Positive 2. So you're going to say minus 2 because the minimum area of this occurs when you get 0 squared. So how do I turn 2 squared into 0 squared? I subtract 2 and then square it. So that's why we're writing that. All right. So what else do we know? Well, if we put 2 in, we can find the y value that goes with it. So minus 24 cut in half, minus 12. So I'll put it in. If you put it in, I guess I got to do it for you. We talked today about squaring first. 2 squared is 4 times 3 is 12. 2 times negative 12 is negative 24. Twice the must be a coincidence. Plus 7. So that's minus 12 plus 7, which is minus 5. So we now know that this is 2 comma negative 5. Boy, that's the most important value on the board right there. All right. And what else do you know about these things, or do I want you to know? I want you to know what 7 is. Y-intercept. Y-intercept is to the left, 2 zeros to the left, which means it's on the decreasing side, which kind of new without having to do it this way. And I'll explain why that works later. All right, so there's your sketch. That was a lot of writing in a small area. I hope it was enough to follow, but you can always replay these things slow. Maybe there's a place to slow my talking down. All right, here we go. But I can't. Because I got places to go, miles to go before I sleep here. All right, so minus b over 2a. I hope you remember that. All right, so the next problem, 3, 7, 8, 10, 8, 11. What the heck am I doing? Oh, I'm writing the equation. So I'm trying to write the equation of 3, 7, 8, 11. I want to try to get this. I want to see if I can nail this on Desmos without having to put it in Desmos. Well, 3, 7. I think I just highlighted the vertex. All right, it's minimum. Smallest area you can get is 0. That happens at 3. Okay, if you can get something smaller than 0 out of x minus 3 squared, put any number you want. If it comes out smaller than 0, let me know. We're going to write a new textbook. Okay, so now, what am I looking at? I'm not looking at linear change. That's to the 1. When I put the second number in here, the second x value, 8. 8 minus 3 gets me a change of 5. Well, this is not linear. This is quadratic. What do I get when I put an 8 in there? I get 25 units of change. If I change 7 by 25, does it take me to 11? I don't think so. Therefore, I don't want that kind of change. I only want a partial amount of that. So 3, 7 gets us the vertex. And now I'm going to put the number 8 in so you can see it work. What's 8 minus 3? 5. 5 squared is 25. How many times is 25 going to 25? Once. What's 4 times 1? 4. And what's 4 plus 7? My correct destination. Your luggage ended up at the right airport. Good for you. Okay, so that's what you're trying to learn how to do, and that's what you're trying to learn how to do enough times that you remember it when you go to Algebra 2. All right, so next question. Then somebody can build off it, take you further in your understanding. Okay, now I'm looking at number 11. Oh, this is good. You did such a good job with factoring. This is a sum. This is now expressed as a product. What do we got? We have 5x times 3 gets me the first term. And then I guess plus 2x gets me the second term. And you did a real good job with that this afternoon. So x squared plus 12x minus 28. That's a sum and difference. My hurrying is costing me time. Think I'll ever learn? No. You did this, right? Did a pretty good job with that. You got your x, you got your x. Two numbers multiply out to 28 that are 12 apart. 2 and 14. Who wins? Who wins? The positive wins, so I better make it 14, the stronger player. There you go. Now you have a product. Used to be a sum and a difference. That's called factoring. All right, we got another couple of factors. X squared minus y squared. Some of you might not have gotten to this, but on Monday we talked about something like 16 minus 9. We know it's 7. And it turns out that you work with the square roots. Square root of 16 is 4. The square root of 3 is 9. So 7 could have also been written as the sum of the square roots times the difference of the square roots. And you can draw the reason why. And I'm not going to, but maybe at some point I will, but not right now. Okay, so x squared minus y squared, x plus y, x minus y. You should multiply it out. X times x is x squared, x times minus y is minus xy. Y times x is plus xy, y times minus y is minus y squared. So if those were numbers, that's where they would go. And minus and the plus cancels. And it sure looks like I'm back to x squared minus y squared. Now it's a product. It used to be a difference. We call that a difference of two squares. That square has x as a square root. That square has y. The sum of the square roots times the difference of the square roots. And they can come to you in more complicated form than that. But anything can be written, any subtraction can be written as the sum of the square roots times the difference of the square roots, whether they're user-friendly numbers or not. All right, some of you got here, some of you got the 4x to the 7y to the 5th. And plus 6x y to the 8, I think. I hope that's what's written, but that's what I'm going to do. What do 4 and 6 have in common? 2. What do x to the 7 and x have in common? X. What do the y to the 5th and y to the 8 have in common? Y to the 5th. I'll show you that. Here's y to the 5th. Y to the 8th is y to the 5th times y to the 3rd. Right? And we'll show that. We haven't really talked about, the rule of exponents here. Yeah, I'm hoping you did in your pre-algebra class. So what do they have in common? Y to the 5th. So how do I get from here back? Looks like my x's need more. And it looks like 2 times 2 gets me 4. So that's good. I need x times something to get to the 7. I guess I need 6 more. And y to the 5th is already there, so I don't do anything with that. How do I get to 6 times 2? I need 3. I already got the x, but I got 5 over here. Looks like I need 3 more. All right, we want to get good at that. We got to be able to know our rules of exponents. So we'll develop that further going along. All right, now I've got functional notation. F of x. F of x equals x minus 7. And g of x, I'll write it in f of x. Yeah, f of x equals x minus 7. And g of x is a different calculation. Well, it's a quadratic. X squared minus 8x minus 20. Right? So if you, let's see, what have I asked for first? G of 2. G of 2. Well, I'm sure as heck not going to plug 2 into this function. It's got a different letter denoting what it is. So I'm going to plug it in over here. So G of 2 is equal to 2 squared minus 8 times 2 minus 20. And so what? 4 minus 16, negative 12, negative 32 is what I'm getting. Again, maybe done too fast, maybe wrong. I think it's right. Then we're doing the y-intercepts. All right, so what are the y-intercepts? Well, that means you're going to plug in 0, you get a 7. So the y-intercept of this is 0, 7. Over here, the y-intercept of this is plug a 0 in, the first 2 terms cancel, minus 20. So the y-intercept, this graph goes through 0, negative 20. And this graph goes through 0, 7. Because I think we're going to sketch these next. So I might as well leave those points on there. Yeah, sketch, yeah. All right, so it's a linear function, right? And if I put some numbers in, like the number 1 minus 7, what the heck, I made a real mistake there. Hopefully you saw me make it. 0, negative 7, sorry. So that's careless on my part, but corrected, fortunately, because I started doing the problem a different way. Good thing to remember, final exams, big exams, do it 2 different ways. If they don't match up, did something dumb, and I just did something dumb. So if I put in, and I did it 3 different ways, right? I'm actually plugging a number in, I'm putting in a 1. And so 1 minus 7 is negative 6. 1 gets me negative 6. Put a 2 in, gets you negative 5. 2 gets you negative 5. You start to see that you're going over 1, up 1, over 1, up 1, right? Because that's what's in front of the x, 1 over 1. And you get that linear function. And that's slope intercept form because we started with a y-intercept. And now I'm showing you slope. Okay, so that's that graph. It's linear. This graph is quadratic. We know the y-intercept. How would we go about tackling this? Well, I think seeing that, and maybe you do, some of you do right now, there's different ways. There's 4 or 5 different ways to visualize this. You did a lot of work with factoring, so I'm going to factor it. X minus 10, can I do that? Yes, 10 and 2, right? X minus 10 and x plus 2. Do I have that? Yeah, I got that right. So what do we now know? We know the x-intercepts now, which is something we're going to do later anyway, so I won't do it now. We're finding the x-intercepts. And since I have this over here, what makes it 0 is this x-intercept. So what x minus 7 equals 0? Oh, 7 is the x-intercept of this one. We have two x-intercepts here, one at -2. That gets me 0, right? If I set this thing to 0, critical number is -2 and also 10. So 10's over here. Put that there. I know those roots. So what does this look like? It looks like I'm going to hit the thermostat. It's cup shape up. So it's going to start to look like this. I'm going to have to go under that thermostat and then back up. So that's the graph. 3 points makes the perfect graph. I don't have to give you the vertex, but let's find it. How would you find the vertex here? Well, it's got to be between -2 and 10. Right? So 10 minus 2 is 8. 8 divided by 2 is 4. That ought to equal minus b over 2a. That ought to give us minus b over 2a minus b, 8 divided by 2 times 1. Yeah, that's also 4. So there's different ways to get it. And how do you get the y? Well, you can either plug it in here or you can plug it in here. I think I'll plug it in the factor form. I think it'll be easier. 4 minus 10, -6. 4 plus 2, 6. Oh, that must be a coincidence that they're the same number but opposite signs. Must be a coincidence in the factor form. Yeah. And so what do I have? I forgot what I'm doing. I absolutely forgot what I'm doing. Oh, I'm multiplying, right? So that's -36. Okay. There you go. Okay. So much for that. Now we have a few problems, mechanical problems that we're just starting to learn the language of exponents. You haven't heard it much. So, you know, it might not be there at all in your brain right now, but maybe it is. I know Anthony had one answer right there, and I think somebody else answered a couple right, just a little bit of practice. So log 4, we didn't do this. I forgot what that means. We talked about that on Monday morning. Oh yeah, the value of the exponent. Value of exponent. That's what your brain is supposed to translate language that you put on top of a 4 to get us a known number. We don't know what that number is, but we're looking for the exponent. And guess what? If this is an exponent and it equals something, then 2 is an exponent. 2 is an exponent. All right. So where do you put exponents? You put them on top of bases. So 4 to the 2 equals x. That means x is 16. Is that the exponent you put on top of this to get that? Yeah, because I could write 16 as 4 to the 2. And if this is asking me for an exponent on top of 4, I think I see one. Now, we're going to do a whole lot more problems where we look at, you know, more exponential activity than that. So your answer was 16. I don't think we covered that. Many people got to that in the workshop this morning. Okay, so now what do we have? Now we have next one, 22, I think. Problem 22 was, I should have been doing that. Log, exponent. So we're looking for the exponent that turns a 3 into a 27. Well, we said 3, because 3 times 3 is 9, times 3 is 27. 27 is 3 to the 3, and we're looking for the exponent on top of 3. Well, there's the 3. What's the exponent on top of it? A 3. Okay. Logarithms in the, I think it was 1600s, Napier, Spanish nobleman or priest, I think he was a nobleman, spent 20 years writing log tables, and the information that he provided the world was so important that there was a period of enlightenment, is what it was called, the Enlightenment period, when people started to do work with long distances, because exponentials, they worked with the exponents, just the exponents. And then at the end, brought the exponents back into play to find those huge numbers. Okay. Copernicus, people like that, astronomers. Okay, so we're just starting to talk about logs. Am I done? Are there more problems? Oh, they're up top, yes. 8 to the -2/3. That's what we finished with today, yes. So we have a negative symbol, that means do something. We have a 2, that means do something. And we have a 3 in the denominator, and that means you're doing something. And we said the order that you do things in doesn't matter. So where's the challenge here? The challenge here is that 3. What that 3 means is you're taking the cube root of 8. What's the cube root of 8? The number times itself 3 times, that gives us 8. And what is that number? 2. So if I do this operation, if I perform this operation, I have changed this number into that, that still remains. I don't think you have a problem with 2 squared. That really is the number 4. 2 squared is the number 4, but I still have this minus sign. And I'll put a 1 there. All right, so what is 4 to the minus 1? It means that 4 is in the denominator more than it's in the numerator. So that becomes 4 over 1. We talked about this as a flip, reciprocation. We can use the word flip. Flip the number. So our final answer, 1 over 4. And of course, you're going to be doing, when I write a worksheet up tonight, you're doing it again. Is that what we're doing tomorrow morning? Get another worksheet. You got to do the work. All right, what else we got? We got 25 to the minus 1/2. Same thing. Okay. And again, the real challenge here is, what does this 2 mean for you to do? Well, it's not a 3 anymore. 3 was a cube root. So that's telling you to do this to the number 25. That's what this is telling you to do. Take the square root of 25. I think we know what that is. It's 5. And we still have to the minus 1. Same thing as last time. 5 over 1 becomes 1 over 5. You'll do fine with that with a little practice. All right, so what's next? 1/9 to the minus 1/2. Okay, you have a choice. You can either do the minus or you can do the 1/2. I think you should do the minus. Because that makes the fraction 9 over 1, and you don't even really have to write the 1. And you're doing something to the 1/2. What does that mean? It means this. That's a square root. So what's this answer? 3. All right, so those are your 25 problems. I'm going to end the video, I'm going to upload it, and you play it. And even if you don't understand something, at least you hear it. It's going to change the synapses in the brain a little bit. Maybe you'll hear it again in connection. All right, so let me get out of here.